Rahim. Good evening, guys. Today in this video, I will explain some important information about the convex lens. Okay, the purpose will be how we can calculate the focal length of convex lens. That's mean from the middle will be bigger than from the other area. It's the convex lens, or we can say the converging lens, because will converge all the refracted rays in the focal point. This diagram illustrates these words, how are all the parallel light rays refracted in the same point or converge in the same point. Okay, we will calculate the focal point, the focal length, by using two methods. The first one by using the focal length law directly, and second one by using the graphical method by explain the relation between the x, y, and I will explain all of that in the next slides. Why is the converging lens, like I said before? Because all of the parallel light rays will refracted on the same focal point, or we can say the converging point. What is the focal length? Is the distance between the focal point and the center of this lens. What is the focal point? Is the point where all the refracted rays will converge inside it. Now, let's take an idea about how we can take a look, or how we can take a look to everything by using the necessary element. This element is the light. Okay, how by the reflection we can take a look to everything by the reflection rays from the unknown object. The refracted rays to my eyes will be the reason of my vision, or can say, or it's give me opportunity to take a look to everything by using the reflection process. It's between two media, for example, air, glass, and by using another angle will reflect it to another direction with the same media, the reflection, and why this glass looks like that, because here the light speed here, it's different from the same pen inside the same pencil inside the water, because here the light speed here is less than in the air. By that, the picture will be is slowed little bit from the same pencil in the air. Change in speed, which speed in light speed and absorption. Is why this apple is red, because it's absorbed all the other wavelengths of the light, other color or other colors of the light, and absorbed just the red one. Here the convex lens uses a microscope to magnify the bacteria molecule, bacteria bodies. Okay, that's according to its size. We will select the appropriate lens, and as a magnifying glass to produce a magnified image of an object, like this dentist and with his patient, to correct long side defect by using this lens to correct the defect inside this lens by using this converging lens, and all the reflected rays will flow from the same point. This point is the focal point. Okay, I think this picture is illustrated all of the important information related with the convex lens, how we can use it to see better. Here, our apertures will be the light source, the picture, the lens, convex lens, and this is the screen. It's the metric ruler. Here, let's determine the focal, let's calculate the focal length by using the focal length directly by using this focal length law. Inverse of the focal distance equal inverse u plus inverse v. Which one is the v? The shorter distance is the v from the retina, from the eyes to the lens, and from lens to and picture is u. Okay, but let's simplify this focal length law to be f equal u multiply v divided on u plus v. The equation number 3, and we will use it to calculate the focal length directly, and by using the graphical method by put u multiply v at y and u plus v at x. Here, like I said before, the relation between them must be linear relation. By that, we have opportunity to calculate the slope. Slope equal here u multiply v divided on v plus u. That's equal what? Let's take a look to equation number 3. By that, our conclusion will be slope equal focal length. By calculate focal length, we can calculate the slope, we can calculate the focal length from the graphical method. Here, from these two pictures, we can say this lens, the convex lens, we can smaller and take a look or produce a big and small image by using the same convex lens, but just by change the distance between them, between the screen lens, between the screen and the picture. Okay. Now let's take an example and solve it together. Determine the focal length to dental length according to the column below. This column by using all of the focal length and graphical methods and compare between them. I have V, the shorter distance from the eyes to the convex lens. D, that's mean the distance from the eyes to an image, the total distance. That's mean U plus V. Let's solve it. From this the focal length law, we simplified it to be equation number 3. Here I have V already, U is D minus V, all of these results. U plus V is the D, the same, but with a different name. U multiply V, and we can say approximately it equal, for example, the first result, 1070. It will be easier to plot them by using this way, and the results by using the focal length directly is all of these 4 results are near from each other. That means our results are acceptable. Let's calculate the average of them to take the best results. Okay, will be 712 centimeter. Now, by using the graphical method, at x u plus v, at y u multiply v. At x-axis, I said each 2 centimeters equal 10 centimeters of u plus v or of d. 1 centimeter at y equal 100 centimeter square of u multiply v. By that, I have this slope. From this red line, I selected the irregular point, here. It's outside the oblique line because that will be outside the slope calculations. From these equations, slope equal 12 to 33 centimeters. That's mean the focal length. By that, it's the focal length from the graphical side, graphical method. All of the results at the graphical method and by using the focal length directly are near from each other. That means they are acceptable. But which one is the better? From graphical method, it's the better because simply it's the results, it's without the irregular point positions. By that, it's the best. It's near from the fact more than by using the concave law, convex law. Sorry, here it's mistake, convex law. By using the convex law directly, focal length to convex law directly, because here we can't say which one is the irregular point from them, but from graphical side, from this method, from this arrow, it gives us the opportunity to say which one is the irregular point, because by that the result will be better. All of these it's written there, and which one is the best. The relation between u multiply v and u plus v is linear relation, and all of these results from the law and from the graphical side are near from each other. Thank you for your listening, your watching. Have a good day and see you next video. I will send your homework soon.